Welcome back, algebrists. Today we are going to continue in Chapter 2, Section 1, where our entire focus has been on graphing quadratics using that lovely vertex form that's up there on that board. Okay, today, instead of just saying, here's an equation, let's graph it, I'm going to ask for your help with something. We're going to find a quadratic. So find the quadratic with, and I'm going to give us some requirements that we need to make this thing meet. So on our first one, we'll do this together, but I want ideas. Something has to get thrown out, but I'll call on people. I want the quadratic with a vertex at the point, and let's make sure I get a nice one. I want my vertex to live at the point 1, -4. And more than just that, a point on the graph of the parabola. So when I say on the graph, I mean on the function itself. And a point that we'll define as just 1, -4. And I'm going to switch color on mine just so it's a little bit easier. 1, -4. I'm also going to change this color. Whoa, did I just give the same point?
Yeah.
Gosh darn it.
It's all right.
It won't be though, because there's not going to get an answer. Psych. We're going to say at -2, -1. Okay. So 1, -4, right? Okay. All right. So here we are. In this form that we have, and I'm going to write it up on the board just so I can make it a little bit clearer. And maybe that would be the first thing. If I'm trying to write a quadratic, I know there's two options. It is either this guy, ax squared plus bx plus c, which we have not really talked about at all. Like, other than saying it exists, we haven't talked about this one. Or it's this other form that I'm going to write here. It is y is equal to a times x minus h squared plus k. Even if you think you know it, or you do know it, think you know it, that was a rude thing to say. If you know this formula, I still think there's value in writing it here, because these problems get super duper easy if you show clean work. So let's check it out. Right now, I'm at a loss. If only h and k were representative of something real specific in my problem. My vertex. Well, gosh darn, if only I knew my vertex.
1 and -4.
Oh, I do. Do I know what h is?
1.
H is 1, and what's k? So we're going to take 2 steps for this. But at this point in time, I'm going to rewrite this entire thing, and I'm going to leave it blank because I'm going to match my colors. I know that I get y is equal to a times x minus 1, and it's squared, plus k is what? So instead of saying plus -4, which is correct, is there a better way I can write it? Okay, I'll write it on -4 on the next one. What did I just do? When you say it, be specific. Good, and I'm just going to write it as plug in h, k. So all I've done is, in my formula, I've noticed. Now, this is so close to being done already. When we actually graph them, if you look at any of the other examples we did, we never have an x written or a y, right? Those stay x and y in our equations, but we always had a number for a. So this question essentially becomes, how on earth can we find a? Well, right now there's 3 unknowns, right? Y and a and x, which makes it hard to solve from one equation. It would be a really big system of equations to solve for 3 variables. Unless we knew that there was an x and a y that we could plug in because it's already on the graph. Well, gosh darn, look at that. There's an x and a y we can use. This is an x and a y right there. That our equation just so happens to have an x and a y. What am I going to plug in for this y value right here? -1 is now equal to, I don't know a still. What are we going to plug in for that x? -2. And then all my colors are going to be wonky. -1 squared. Okay, squared. And I'm just going to call this -4, because plus and negative is just minus. If I wanted to annotate this, I just plugged in what? So good, I'm just going to say xy. All right, here's my challenge for you. We will talk through it if need be, 100%. And I'll show my work here, But I'm going to give you guys a minute. Find me A. Plug in, simplify. I want to see what you guys come up with for the value of A on this problem. You're using this. You are trying to solve this for A. You're trying to do it on your head.
Is it decimal?
I don't remember. It could be. I have a fraction. Like, oh, I'm sorry. So, negative 3. Okay, so 9 minus 4.
Yeah.
Okay, so careful. Right here. I want you to write 9 because it's connected here, but then there's an addition. So write A right of it. And now we can't combine these right terms. So I would just erase just here down, just these lines right here. And then let's solve it. Like there's a little mistake in there that's easy to fix. All right, so here I am and I feel silly because I'm your teacher and I just don't know what to do. Help?
I don't know how to get
Square.
So what do you want me to square? How do I square this?
No.
What's negative 2 minus 1?
Negative 3.
Okay, so I'm going to do it step by step. Everybody agree that when we plug in and just simplify inside my parentheses is what I get? Okay, I'm not done yet, just so you know. But we're cool here.
Yeah.
Okay, what happens next according to order of operations? So we square it. What's negative 3 squared? Is it negative 9?
Oh, shoot.
So this looks annoying because we usually call it 9a, but I'm going to call it a times 9. It's the same thing. I'm solving for a. I don't care about making it look nice right now. There's still a minus 4 over here. I want to isolate a on one side. How? Let's add 4. When I add 4 to both sides, and I wish I had a really easy button to switch colors, but I don't. When I add 4 to both sides, I get what over here? 3 is equal to, now, if you would like to write it as 9a, you can. I have no preference, honestly. I'm going to write it as a times 9. Same thing, though, right? If I want to solve for a, there's only one more step. Divide by 9. So divide by 9, divide by 9. And somebody I just told had the wrong sign, and I was wrong. I don't know who I told that to. I don't know who it was. What's 3 over 9? Does that simplify?
Yeah.
1/3. Now, notice, at this point, right here, we were really close to having it. The only thing that we didn't know yet was a, right? But we just found it. So let's backtrack to just that part where all we needed was a, because we already have the vertex, and write our answer. Therefore, and I use these 3 lovely dots, instead of a right here, what am I going to plug in? 1/3. And I'm left with what inside my parentheses? So careful. X minus 1 minus 4. And I wrote my dots where I'd put it, so this is going to be annoying, but equals y. It's backward. It's normally y equals, but I already put these dots. Okay. These problems seem super duper hard. Hopefully it doesn't feel like unreasonably hard just now. Should we do another one like this?
Yes.
Okay, and by we, I'm going to give you guys a head start. I want you to work with one another. Not by copying. Should we just make up our own?
Sure.
Okay. I want, on this one, I want a vertex. at the point -4, -10. And I want a point, we'll say and point, on the graph, and I'm just going to give it -2, -6. I want you guys to do the same thing, and then we're going to do some physics together. Cool. I'm going to give you guys a couple minutes. I'll give you a head start. Chat it out. Don't just sit there waiting for the answer to show up on the board, because inevitably you will get it, because it will be on the board, but you're not learning if you're not trying. Cool, 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 cool. We'll give us a couple minutes. I'm going to walk around to get my steps and to make sure that you can ask questions. I will not look over your papers without asking. When we did this first problem, we did 2 lines to plug in HK, and then we did another line to plug in XY, right? Can I just plug in all of my H's and K's and X's and Y's right here? Jade, I'm going to ask you to stop, okay? Okay. In one line, I just looked Y, X, H, and K, and I just plugged them in. Okay, if you want to take 2 steps, do it. I'm cool with that. But you can realistically do it in 1, as long as you recognize what these things are. When we get here, help me with the algebra. -6 equals A times, what's in these parentheses? 2, because minus a negative becomes plus a positive, is how I do it. So there's a 2 there, squared minus 10. Okay, I'm going to add 10 to both sides, and then I'm going to rewrite it, but I'm also going to expand this. So on the left side, -6 plus 10 is hard for me, but I'll switch the order. What's 10 minus 6? Okay, so 4 is equal to A times, what's 2 squared?
4.
And one more step. What would you like me to do to both sides? By 4 and by 4. What do we get for A?
1.
Love it. Beatrice, when you fixed your easy mistake to make, did you get 1?
I got 1, but
You got -6 over 6.
yeah.
I don't think you're wrong. I think that we just did stuff a little bit different. And it's okay. I'll double check. But are we done just as soon as we write A equals 1? No, we need the equation. So I'm going to use this, therefore. It doesn't really matter what symbol. I'll just use a bullet point rather. We now know that y is equal to A, which is 1. I wouldn't normally write it, but you can. Key in, make sure you're focusing, not distracting. What goes in these parentheses?
Wait.
You forget.
X plus
You forgot
4.
You forget.
Was there-
Oh, there is one there.
X minus, what are we subtracting?
Plus 4.
Oh, so x minus -4 becomes x plus 4 squared,
Minus 10.
and we're done. We're done. Yep, that's it.
Wait,
Oh.
I don't understand how we got that equation.
So are you cool with A equals 1?
Yes.
So when we look at this, Lucy, great question. For this equation to work, if we know HK, the only other thing we need is 1, or A, rather. In this case, we figured out it was 1. All that I didn't do was write I guess I did. I wrote the 1 here. If we already know the vertex, we're good. Yep, you just need A and the vertex. All right, so this one. Feels okay, feels awful.
Good. I think
All
I
right.
should practice it more, and then I'll give you-
And we're going to practice another one right now, but we're going to do a slightly different problem. We're going to do a word problem. And we're going to do some physics, is what we're going to do.
Oh, okay.
Okay, so Algebra 2, I'll make a claim to you guys. This is the first class where you can kind of start to see some very realistic math showing up. Now, on the flip side of that, the real math that goes into physics is not Algebra 2. It's calculus. Isaac Newton developed calculus to do physics. We're not in a calc class. That's okay. We can still do a bunch of physics without it. So, for this, I'm going to pause it. For this, at 0 seconds, what's its height? So do you agree, and we had it a second ago, but there's a point on my graph at 0, 4. Okay, if I have a parabola, what do you call that very highest point that it reaches? It has a name. So that's its height, but I can't. It's the vertex. At what time do we reach our vertex? So do you guys agree that realistically, if we just take the context out of it, we just have this. The point that's on it is 0, 4. And the vertex, you just told me, was at 2 seconds. It's at 10 feet. You have a point now and a vertex. What the problems that we just solved a minute ago, what were we given? Oh my gosh, it's the exact same problem. I want you guys to get to this, like you're going to use this information, and you can use y if you want to, that's fine. but you're going to get to this. I want you to find me a just like we had a moment ago. You're going to find all these values for me, and then we're going to jump back in together. It's the same problem, just with a context this time. Plug in plug in x, y, h, and k. Get me the value of a, and we're going to meet back up. Okay, so when I'm doing this problem, I'm going to plug in x and y and h and k all in one line. What am I going to plug in for y? 4 equals, I don't know what a is yet. What am I going to plug in for x? 0 minus, what's h?
2.
I'll square that whole thing, and I add 10. I'm going to solve this for a. If you made a mistake, own it. I want to know where it happened. If everybody knows where a mistake happens, it's probably going to be a common one, and we can avoid it. So here's my next line. 4 equals a times 4 plus 10. If you made a mistake, the one most common mistake I would expect is somebody might have a negative 4 written here. If you have a negative 4, do you know what you've done wrong? What? Okay, I thought you were giving me a yes, my bad.
Oh, no.
If you have a negative 4, it's because you looked at negative 2 squared, and you said negative 2 squared is negative 4. But remember, it's negative 2 times negative 2. Okay. Help me solve for a. What would you do? Subtract 10 from both sides. I get a negative 6 is equal to, and it might be more natural if I write 4a rather than a4, because this looks wonky. One more step. What do we divide by?
6, 4.
Let's divide both sides by 4. And then this is going to bug me, and I hope it bugs you guys, but I don't know. Does this fraction bother you?
Yes.
Why?
Because the biggest number's on the top. That's why it bothers me.
Okay, so not why it bothers me, but that's okay. I would never call this 1.5. Does something go into both 6 and 4?
Yeah.
What? So let's take a 2 out of both of them. Negative 3 over 2? Okay. So at this point, all we've reached, and if you didn't write this last part, is we just found a for our function. Now, I used x here. What's our actual function supposed to use? T. So anywhere that there's an x, I'm just going to write a t instead for now. We have just found that h of t instead of y is equal to negative 3/2 t minus, what's that h value that we already decided? 2 squared plus 10. All I've done is instead of x and y, I've used h of t and t. Question, Jade?
No.
Okay. Before we continue, questions, Ken?
What would that mean in the context of the ball went down to -3 halves?
Nope. All that means is that my parabola has gotten a little bit thinner than the parent function, and it's been flipped upside down. So our parabola looks like this, which it should, because it has a maximum height. Like, in the context of the problem, it doesn't tell me a ton about it, and so we start using it. Other than I know it does this. When's up? Hold off until this one, unless you're going to pop. Okay. Does this form look exactly like this?
Yeah.
So,
There's no.
I wouldn't say yeah and then kinda. It's either yes or no. Is it exactly something t squared plus something t plus t? You say that. Where's the t squared written here? So it's not written though, is it? It could be, and it will be here in a second. But do you agree we don't have exactly some number t squared? We don't write exactly this yet.
Yes.
Like, maybe all the pieces are there, but we're not there. There's a wrong answer to this question. I want you guys to shout out for me the F word that we're about to use.
Fraction.
So that's a good F word in math, but it's not the one I'm after.
Flip.
I need to clean this up, because I want it to look like this. Foil.
Foil.
We are going to foil real quick. What does foiling mean?
I don't know.
Okay.
Oh,
Distributing something that I don't remember.
You're distributing. So let's take this step by step. I don't really care if you know the word foil or not. What does it mean to square something?
multiplied by itself.
So do you guys agree that if we wanted to really see what this means, it's negative 3/2, and then I'm going to use brackets just to keep stuff separated nicely. T minus 2 squared literally means t minus 2 times what? T minus 2. This is literally what it means to square something, plus 10. Now, when you guys, so just so you know, there's only going to be like 3 answers, and we all know the wrong one. The F word in math, I've never had a class shout out the one that's not the right answer. Please don't be that group. Cool. I need to multiply these. And Beatrice made a comment a second ago, she said distribution, which is really what I would rather have. Yes, miss?
I was writing it down, so if
No,
you
you're
said
good.
it, was paying attention. Did you write it down twice because it's squared?
Yep, so when you square something, like 5 squared is just 5 times 5, right? So t minus 2 squared is just t minus 2 times t minus 2.
Okay.
Now, the word FOIL is an acronym. It stands for something, like just like PEMDAS, but that's not a real word. FOIL stands for first, outside, inside, last. Okay, whether you memorize that or not, doesn't matter to me. But if you remember ever hearing that, I assume everybody here has. I don't know, depending on how long, have you ever heard the word FOIL in math?
Yes.
So you have, because you took math here. If in the Philippines, do you guys use the word FOIL? Really, you do? Or are you just agreeing with me because you think that's the right answer?
Yeah.
Okay, so check it out. What's the first term of this one? And the first term of this one? F is for first. I draw lines rather than writing it. I'm going to draw my distributions. First terms multiply. Now, we're going to expand this together. I still have a negative 3/2 out here. Let's just clean up all of this stuff. What's t times t?
2t squared.
2t is t plus t. What if you multiply them? T squared. T times t. There's first times first. In FOIL, that's our first. What's the O? Outside. In just this piece, just these two pieces, what's the outside pieces? This side's outside is a t. What's the most outer piece over here? Almost. -2. So when you're drawing your distributions, if you struggle with it, I would rather do the lines. Here's our outside pieces. What's t times -2? Good. -2t. Outside is what we just did. What does the I in FOIL stand for? The inner or inside. What is the most inside piece of this one? So that's outside. What about the inside? Like this is the inner section, right? -2, and what's the inside piece here? So let's multiply those two. What's -2 times t again? -2t. And then finally, what does the L in FOIL stand for? The last. So nope. I agree that that's the last one here, but we're only looking right here, Kian. What's the last term of this first piece? And the last term of this one? There's our lasts. What's -2 times -2? +4. Okay. My guess is this is probably feeling kind of familiar. Whether you were good at it or not isn't the question. I will tell you, I legitimately think that everybody in here is capable, like within a day, of being able to FOIL in your head. You might not agree with me, but I guarantee that if I just ask these questions in the right way and you think about it like this, you can do it in your head. But here's the cool thing. Do I really care if you can do it in your head? Not even a little bit. So let's just clean this up. This is still a -3/2 out front. What is all this clean up to be? And I'm going to change it back to parentheses because it's a little bit easier and nicer. Is there any other t squareds inside? It's just one of them, right? So I'm going to write just a single t squared. Are there any like terms inside of here that I can combine?
Yes.
What's -2t minus 2t? -4t. And then the only thing that we have left is a +4. All right. We have FOILed. Now, all the rest of this is just leading into what we're going to look at later in the section, just so you know, like this isn't for just because. There's a reason we're doing this. What happens with this and all of this? It distributes. Okay, if you hate fractions, here's the good news. They're going to be easy. What's -3/2 times t squared? -3/2 t squared. That's it. When we do the next piece, this one's a little harder. What's -3/2? Or if we just treat it like numerator to numerator, because there's really an over 1 here, what's -3 times -4? Try again. So you're right, and you are right. -3 times -4 is +12, and over 2. Declan had just called it a 6. Is that okay if you just jump right to 6?
Yes.
If you can do the multiplication in your head, cool. I'm good with it. I'm trying to make sure that if you can't, you have an option for it. Okay, last one. It's going to be +12 over 2 again, right? And then all that I've distributed, so I don't need parentheses anymore. There's one more thing. Plus 10. Now, somebody noticed, and multiple somebodies, that when I clean this up, 12 over 2 is 6. So 6t. And then this is plus 6 plus 10, right? Which should be what? And I have a mistake, I think. Jade might have just saw it. What did we say negative 3 halves times 4 was? I wrote positive. Should I have? No, I just made a mistake. That's a negative because I was excited about you guys doing well with this. That's not, I mean, it's kind of true. I am excited that you guys are doing well, but you're not at fault for my mistake, just to be clear. Okay, so this is negative 6 then, right? So negative 6 plus 10.
Plus 4.
Do we now have something that is very much in exactly something t squared plus something t plus something c? We are done. Here's the bigger question. What did we just find? Like, what is the value of ever having this? So check this out. If I have something that follows all this data, like there's something that I can throw up and at 2 seconds it's at that height. If I want to know, like hypothetically, if I throw this up, will it eventually hit the ground?
Yeah.
Okay, if I asked you right now, what's its height? 0. Could you plug in a 0 for height and somehow possibly find the time t that happened? Now you would have to factor, and you may not remember how to do that, but there's a way to solve this problem. We could find the time where this thing hits the ground. If I want to know how high up is it after 1 second, all I need to do is plug in what for my time? We could find the height of this object after 1 second, or 3 seconds, or any number that we ever want. We can do all sorts of predictions with this model that we have. That is a very realistic model that one would see in physics. Okay, the part about this that is really gross, I hope that you guys all agree, this is the part that's just kind of yuck. Up to this point, do we feel okay? You guys were talking about how the wind wasn't blowing anymore. That was the wind blowing.
White in the air. What's that? Cotton?
Yeah, it's from the reeds, not, I don't know, they look like hot dogs. Wild corn dogs, whatever you call those. All right, they're not really wild corn dogs. Don't eat them, they're filled with a bunch of seeds.
We don't have those here.
No, but there's plants that have seeds that are similar. Yep. Okay, so for this, if you are completely cool up to here, or even kind of cool up to here, I'm happy with where you're at. If you are completely cool with all of this, I'm doubly cool with where we're all at, but I understand that you're rusty, it's been a few years, totally cool. I can't stop saying cool. Cool, 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 cool. All right. For tonight, I don't think I need to add any problems. Do you want a word problem?
No.
Are you sure?
I'm pretty sure.
All right. Finish the problems that you have.